This is for 1, 2, 4, and 2, 0. We're going to start by plotting the points from here onto our pink graphs. So take your expo marker and we're going to plot our points. And make sure your x-axis is side to side and your y-axis is vertical straight up. 4, 1 is right here. And try to make your points a little small. I like to use just like the corner of the marker. I don't have a bunch of the thin markers, so I have to give everybody fat markers. So bear with me. So this is V. W is originally at 2, 4. And X is at 2, 0. So you should have 3 points. Take a second, make your 3 points from your T-chart. And we're going to connect them to make the same triangle that's on your worksheet, that's on your graph. While you're plotting your points, I'm going to kind of talk about a circle. A circle, if you spin yourself in a circle, that's 360 degrees. If you go in half of a circle, that would be 180 degrees. What we're doing is splitting up into quarters. So if I go a quarter of the way around a circle, that's technically 90 degrees. If I go in half, that's 180 degrees. If I go 3/4, it's 270. If I go in a full circle, it's 360. So 90 plus 90 plus 90 plus 90 makes a 360 degrees. Okay, so what we're going to do is we are going to spin our graph. Our first rotation is going to be 90 degrees counterclockwise about the origin. So it's always about the origin. So we're going to the left because it's counterclockwise. So you're going to spin your graph 90 degrees, basically 1 quadrant to the left. So I'm going to take my graph and I'm going to take just the clear part and I'm going to turn it horizontal 1 direction to the left. So what I mean is I don't want you to have like your little corner thing up here. So we're going to spin it completely side to side, completely horizontal. And then we're going to figure out where X prime would end up, where Y prime would end up, or V, I guess, W, where the new coordinate points end up. And based on those new coordinate points, we're going to create a rule that will help us do this without a graph. So if my graph started here and I went 90 degrees counterclockwise to the left, 1 quadrant, X originally, or V, we'll start with V. V originally was at 4, 1. Where is V at now? -1, 4. W started at 2, 4. Where is W now on our graph? -4, 2. And then where is X at now? 0, 2. So once you have your coordinate points added to your T-chart, we're going to plot these on your worksheet so that way you can visually see where it went. So take a second, plot your points on your worksheet now. And if your expo marker, if you grab an expo marker that does not work, by all means, throw it in the trash can and just grab a new one. -1, 4. 2. 2. So it's spinning around 0, 0. That's the point of rotation. We went to the left 1 quadrant because it's just 90 degrees. 90 degrees means 1 quadrant. Typically, you're always going to go to the left. The only way you're ever going to go to the right is if it said clockwise. Counterclockwise is to the left, clockwise is to the right. So this is counterclockwise, 90 degrees. So we moved 1 quadrant to the left. So if you look at your coordinate points, originally it was 4, 1, 2, 4, 2, 0. Can anybody tell me how the coordinate points changed? What was one of the things that happened? They switched. Okay, they flipped. So instead of X, Y, it goes from Y to X. What else happened? There was one other thing that happened. The X specifically went to negative. So my new X, or the Y value, switched its sign. So what that means is if it was negative, it is now positive. It was positive, now it's negative. So I flip it and I only switch the front number. So now we're going to do the same thing, but now we're going to go 180 degrees counterclockwise. Typically the problems will always say counterclockwise, like this one said counterclockwise. If it says clockwise, you're going to the right. Let's talk about really quick. If I go clockwise, how many quadrants would I have to move if I went to the right instead to end up at this new triangle? If I went 2, this would be 1, 2, I would end up down here. How many would I have to go in total if I went to the right? 1 would end up here. How could I go from here to here if I went to the right instead? It's not 1, not 2. How many would I have to go? 3. So if I went 270 degrees clockwise, so we'll say and 270 degrees clockwise, they're going to take you to the same exact spot. If I went 1 quadrant to the left, or if I went 3 quadrants to the right, I would end up in the same exact location. So the rule is going to be the same for 90 degrees counterclockwise and 270 degree clockwise. Most of the time it's going to be counterclockwise. When in doubt, go to the left. Okay. 95% of the time you're going to the left. You're not going to the right. Okay. So now we're going to do the same thing. We're going to go 180 degrees counterclockwise. This rule will also work for 180 degrees clockwise. And we'll talk about why in a minute. So this triangle is new original coordinate points. So you're going to have to take your finger and you're going to have to smudge out your triangle. And if you don't like the little black stuff on your finger, you can wipe it on the carpet. So smudge out your original triangle you had. Because I had erasers and then I was looking for them yesterday and I could not find them. So I don't know what happened to them. And then make sure you smudge out your triangle and then you reline up your paper so it's nice and vertical. So it's nice and straight up and straight down. We're going to plot H, I, and J on our pink graph. So H is at 0, 3. I is at 3, 4. And J is at 4, 2. Oh, I followed the point wrong. Maybe that looked funny. Okay, so there's our original triangle. 180 degrees is 90 degrees 2 times. So 90 plus 90 makes 180. So that means we're moving it 2 quadrants to the left. So whenever I take my triangle, if I spin it 1 quadrant to the left, that would be perfectly horizontal like we just did. This would be perfectly horizontal. That's 90 degrees counterclockwise. We're going 180 degrees. So basically, your little clear sheet should end up completely upside down. So it should end up in the second quadrant to the left. So it started here. So I moved it 2 times, 90 degrees, 180, because it's 90, 90. So it should end up completely upside down. Your clear sheet should be hopefully completely upside down. So if I start with the first one, H originally was at 0, 3. Where's H at now? 0, -3. I was at 3, 4. Where is I prime at now? -3, -4. And then J was at 4, 2. Where's J prime now? -4, -2. Okay, so I completely flipped upside down. It rotated around the origin. So we're going to take our points that we just made and we're going to plot them on our graph. This moved 2 quadrants to the left because it's 180 degrees, so it's 90 degrees twice. So it's spinning around 0, 0. I went to the left. Now we have to come up with a rule. If I look at the original coordinate points to the new coordinate points, how did my coordinate points change? Did they flip? What flipped technically? The coordinate point itself did not flip. What changed? Just the negatives. So the signs changed, so you flip your sign. So the coordinate point is staying exactly the same. X is still X, Y is still Y. The only thing that changed is they actually became negative. So if they would have started negative, that means that they would now be positive. If they start positive, they end up negative. So it's a sign change. You don't flip the coordinate point, the signs just change. If I went clockwise, if I went to the right, I would still have to move 2 quadrants. So if I went 1, 2, I would still end up in the same exact location. If I went to the left 2, 1, 2, I would still end up in the same location. So that's why 180 and 180 are both going to be this, because there's only 4 quadrants. Okay, so half of 4 is 2. So you're gonna get 2. So now we're gonna do one last one together with our little sheets. If you want to use these whenever you do your assignment, you can. So spin it around so it's nice and perfect again, and erase your triangle. We got one more triangle to do. The triangle that we're going to do next is WXY, and it's like a cute little small triangle. So same thing, we're going to make sure it's set up nice and straight, and then we're going to plot the original WXY coordinate points on our pink graph. And some of you will realize how to do this without this fairly quickly, but people who like visual things and like to see things, this pink thing hopefully is helping your brain process it. Okay. So once you have your triangle, this time we're going to go 270 counterclockwise. So this rule is moving 3 quadrants to the left. That would be the same thing as going 1 quadrant to the right. So whatever rule we come up with, 270 counterclockwise is going to be the same as 90 degrees clockwise. So 270 counterclockwise, that means we're moving 3 quadrants to the left. So when I spin my triangle, this is where it starts. If I go 90 degrees is 1 rotation. That would be 90 degrees. 180 degrees is completely spinning upside down. So this would be 180 degrees where it's nice and upside down. 270, I'm going to move it one more time. So it's going to be horizontal. And it's going to end up beneath where it was. So it started up at this top quadrant. Now it is below it down here. So I spend it 3 times. And now we need to write our new coordinates. So if W was 3, 2, where does W prime end up now? 2, -3. X was 4, 3. Where's X now? 3, -4. And then Y was 4, 1. Where is it now? 1, -4. So now you have your coordinate points. Plot them actually on your graph so you can actually see where they went on your paper. That was a bad place for me. Nice. W. to the past. So this went 3 quadrants. 270 is 3 quadrants. It started here. I went 1, 2, 3. I ended up in the 3rd quadrant, which is the same thing as going 1 quadrant clockwise, the opposite direction. Okay. So if I would have went 1 clockwise, I would end up here. If I went 270 the counterclockwise, I would still end up here. So if I look at my coordinate points, this time it went from 3, 2 to 2, -3. So what's one of the things that changed? It switched. So X became Y, Y became X. So I switched it. And then this time, which value changed? The front one or the back one? The back, the X. So the one in the back is going to change its sign. They flip, back changes its sign. Okay, so now we're going to kind of summarize this. We're going to put all of our rules right here so that way they're nice and in front of your face. So it says a rotation of 90 degrees counterclockwise about the origin. If I go 90 degrees counterclockwise, what is the rule? Somebody said it. -yx. If I do 180, it does not change at all. It does not flip. They just become negative. So it's -x, -y. If I go 270 counterclockwise, they flip and the back number changes. So this is going to be y -x. What happens if I go 360 degrees? They stay the same. So xy stays as xy. That's why they're never going to have you use that one, because then nothing's going to change because it's going to stay exactly the same. Okay. So now without using the graph, just using the formulas, we are going to figure out where our coordinate points would be based on the given situation. So it says, give the coordinates of the point after rotation of 270 counterclockwise. So I am using the formula x, y, little arrow, y, -x. So I'm going to flip my coordinate. The back number changes its sign. So 4, 6 becomes what? 6 -4. B prime, B was -5, 2. I'm going to switch it. And the back number is going to change its sign. So what's it going to be? 2, 5. The 5 was negative. Now it's positive because the back number is changing its sign. C, I'm going to flip it. Back number changes its sign. So what's it going to be? -12, 0. So 0 is neither positive nor negative. So 0 just stays at 0. Okay. Question 2 says, give the coordinates for the points after a rotation of 90 degrees counterclockwise. So 90 degrees, the rule is you're taking your coordinate point, y is, you're changing it to -y, comma, x. So you're flipping it, and the front number is changing its sign. So take a second, try D, E, and F. See if you can figure it out. Take a second. So if D was 4, 6, what would it be now? -6, 4, good. If E was -5, 2, what's it going to be now? -2, -5. And then for F, it was 0, -12. So I'm going to flip it and switch that front. So what's it going to be? 12, 0. The last one is the easiest. This one's easy peasy lemon squeezy. It says give the coordinates of the points after a rotation of 180 degrees. 180 degrees, all it does is change the sign. So it does not flip the coordinate, it just changes the sign. So your xy just turns into -x, -y. So if it's positive, it's negative, negative, it's positive. So M is 4, 6. So what's it going to be now? Thank you. -4, -6. N was -5, 2. So now it's gonna be 5, -2, good. And then P was 0, -12, what's it gonna be now? 0, 12. Okay, on the backside, you can, if you look on the backside real quick,